Hi everyone and welcome to my Go course. In this video we're going to talk about floats in Golang. Golang provides two data types for storing floating point numbers, which are float32 and float64, two different data types of different precision. And Golang, as many other programming languages, implements the IEEE specification number 754. And according to this specification, float32 and float64 have this kind of representation in the memory. So, for instance, float32 is represented this way. It has 32 bits of memory. 1 bit is used for storing the sign, whether it's positive or negative. 8 bits are used to store the exponent, and the rest, 23 bits, are used to store the fraction. And similarly, it's implemented for float64. It has 1 bit for storing the sign, whether it's positive or negative, 11 bits for storing the exponent, and the rest, 52 bits, for storing the fraction. If you want to know more about how floating data types are represented in the memory, you can just Google for any float converters. And for example, I came across and found this converter, and here, for example, you see the representation, and every bit is used, which is used for float32. For example, if I try to enter any value, for example, 1, I'll see that, for example, these exponent bits were changed. They were set to ones. And if I put some fraction value, for example, 5, 1.5, then I also change the mantissa here, which is the fraction type, the fraction part. And if I change it to a negative number, now I expect the sign bit be set to 1. And yes, it was set to 1. And if I try to type more, I'll see how it changes here. So this is approximately how it's represented, how it's implemented according to this specification. Even though it's the JavaScript V-engine implementation, but it looks pretty much the same or similar for the Golang, because both languages implement this IEEE standard. Let's write some code and demonstrate the difference in precision between float32 and float64. For this, let's create two variables, f1 of the data type float32, and give it a value, for example, like this, and variable f2 with the data type float64, and I'll just copy paste this value, and let's print out to the console the values of those variables using the function printf from the fmt package, printf, and I imported this package fmt, and it accepts a formatting string and the arguments. So the formatting string should contain the verbs, the so-called templates. The right name of those is verb. So to print a floating point number, in previous video I used the f verb, but I'll show you another one, the g verb, which is used to print the floating point numbers in the correct precision, in the most suitable precision. Go will choose it for you. So I'm going to print the f2, I'm sorry, it's f1 and f2. So I'm going to print the f2, f1, and f2 numbers. Let's say it's f1 and f2, g, new line sign, and it will be f1 and f2. So let's run this code, go run, and see what will be in the output. So as you see, even though these variables have the same values, but actually when we try to print them out, they have different precisions when printed. For example, for f1, which has the data type of float32, it rounds these last two digits, 8 and 9, it just rounds it to 9. Whereas F2 doesn't round them because float64 has a better precision, and in fact, you can think of it that you can store approximately 5-6 digits of precision using float32 and approximately 15 digits of precision using float64. For example, if I add several zeros in these uh, numbers and I run this code again, I see it rounded it again. So now it just skipped this 9, and whereas the F2, when we printed F2, it didn't skip anything. This kind of notation we use to initialize the variables. It's not the only valid notation. You can also use the so-called scientific notation by using the um, module, the absolute value of the number, and the exponent with the power. For example, minus 20, and I would also like to have like 1.34 exponent 45. And let's run the code and print them out. So as you see, even though I still use this G verb, but Go decided that this number, for example, is too small because it has the exponent power minus 20, and this number is too uh, big because it has exponent power 45. That's why it's decided to print it in the most suitable format for the floating point numbers, and it chose the scientific notation. For example, if I change this number to a simpler number like this, which doesn't need much precision, and I still decide to print them out, Go will choose the most suitable for it and print it in this decimal format. But if I want to print them explicitly in the scientific notation, I need to use the E verb in my F function, printf function. So if I run this code again, both numbers will be printed in the scientific notation. What is also important to mention is that the minimal value for the float point number is actually not the smallest absolute value for the floating point number, float 32 and 64, is not a 0. It's actually close to 0. 0, it's near 0, but it's not 0. So for float 32, it's approximately 1.4 and 10 power at the exponent power minus 45. And for the float 64, it's approximately 4.9 exponent power minus 324. Yes, let's try to print this. Yes, so these are the smallest absolute values for float32. It's not 0. And they also have the maximum values, and those maximum values are stored as constant in the math package in the standard library of Go. And these are, for example, max float32 value, and again, sorry, max float64. I'll clear this. I'll run the code again. And now we see their maximum values of this data type. This math package provides also many different functions for working with numbers, many mathematical functions like sin, cos, cosinus, square root, and so on. So let's say we would like to know the square root of f1, and we would store it in a variable um, square root f1. I'll assign it this value. And it complains because this square root function actually accepts a value of float 64. So if we want to use the value of f1, we need to explicitly convert it to float 64. value by using this notation, data type, and then parentheses. And now we want to print this value, printf, and let's say it's square root of f1, or just let's use the verbs. G is equal to g, and we put f1, and we put the name of this variable. So let's clear this, and let's run the code again. And now we see this. So this is the value of f1, and this is the value of the square root for this variable. I don't know, I think actually it should be, oh sorry, I'm sorry. Here is the square root of this value is equal to this. Great. So you can perform any arithmetic operations with the floating point numbers in Go, and same as you would do with integers, the results of any arithmetic expressions using the floating point numbers is a floating point number. And in some cases, let's say I'll delete this code. There are some cases in arithmetic in which you cannot know the result of the arithmetic expressions. And these are, for example, the division by 0, division 0 by 0, and so on. Let's say we have a floating point number z, which has a type float64, and if we do not initialize it, it will be initialized with its 0 value, which is 0. So let's try to play around a little bit with this. And for example, let's print the value of this variable. We'll just use the println function. So the value itself, the negative value of this variable, the value of 1 divided by z, the value of -1 divided by z, and z divided by z. Let's run this code. And now it's getting interesting, because now we see, okay, the value of this variable is 0. There is actually also a minus 0, a positive infinity when we divide 1 by z, or 1 by 0, and negative infinity if we divide minus 1 by 0, and NaN, which stands for not a number, when we try to divide 0 by 0. And this NaN is actually a constant, and this constant is stored in this math package, NaN, which is the function which returns this NaN, not a number value. So, and let's just play around a little bit with this not a number value. So we'll store this in this nan variable. And what's surprising about this value? We know from arithmetics that any value is equal to itself, and it cannot be, for example, 1 is equal to 1, so it's equal to itself, and 1 cannot be bigger than itself, 1 cannot be bigger than 1, and it can be less than itself, so 1 cannot be less than 1, because 1 is equal to 1. So it's always equal to itself, but it doesn't work with nan. For example, let's play around a little bit with this. So as I said, in arithmetic, any value is equal to itself. Let's test it with none. And any value is not greater than itself. And any value is not less than itself. Let's check it with none. So what's special about none? Let's run this code. I'll clear this first. Go run. And as you see, the second line, the result of all of these expressions is false, false, and false. So nan is actually not equal to itself. and it cannot be bigger than itself, and it cannot be less than itself. So this is kind of strange case, and in this way, actually Go treats these kind of operations. And Go actually has functions like inf and positive and negative inf to return the value of this positive infinity and negative infinity. And also this math package has functions like is, none, to check whether the expression returns a not a number value. For example, if we try to run this, let's print this out. Print ln math is none and z divided by z. And let's run it. And we see that this function returns true because the result of z divided by z, or 0 divided by 0, is not a number and is none. So Go provides you two different data types for storing floating point numbers, which are float32 and float64. Both have different precision, but if you want to work with floating point numbers in your program, I do recommend you, and also Go community recommends you, using the float64 number data type, and because in this case you would avoid um, data loss in some cases when you try to convert, for example, floats into integer data types. That's why try to use this data type because it has the biggest precision among floating point number data types. So this was it about floats in Go. I hope you enjoyed the video. Hit the like button, subscribe to the channel for the future updates. Thanks for watching, and see you in the next one.